Math 2, Unit 5, Worksheet 6, using coordinates to classify quadrilaterals. All right, so what we have is 9 different quadrilaterals on the next couple of pages, and our job is going to be to classify each of those. Now, normally what you can do is you can obviously make an educated guess with your knowledge of quadrilaterals. You can make a guess, and then we will set about using some of our skills that we've acquired to either hopefully prove us right or at least identify what type of quadrilateral it is. We have basically 3 formulas that we use to help us identify those, and you guys will be well versed in them because you used them a lot last unit. The slope formula, we can use the slope to prove 2 sides of a quadrilateral are parallel, like a parallelogram. We could use the slope to prove that 2 diagonals are opposite reciprocals of each other, which means perpendicular. Any questions on that? You guys know what opposite reciprocals mean? So what is the opposite reciprocal of 2/3? Negative 3/2. Good. All right. You guys are smarter than you look. So let's just go ahead and make sure we know the slope formula. We always use lowercase m to identify slope. And I like to just always say delta y over delta x. If you get used to saying that, I think it helps you along the way. Delta in math means difference. So we can say y2 minus y1 over x2 minus x1. And we'll use that quite a bit today to prove sides parallel and also to prove diagonals perpendicular. All right. Now, midpoint. When would we maybe use the midpoint formula? When would we maybe use the midpoint formula? Yeah, maybe to prove that diagonals bisect each other? Wow. Answer's right there. Let's put the midpoint formula down. Remember, the midpoint is just the average of the x's and the average of the y's. Nothing tricky. And finally, we have to, a lot of times, prove the sides of the same length, right? Like maybe trying to prove that a square or a rhombus has 4 congruent sides. So we need to find the length of those sides, which means distance formula. So same length equals congruent. So the distance formula is, so we're going to get some good practice using the distance formula today, and I know how much you guys love that. And remember, that's just a fancy Pythagorean theorem, isn't it? Okay, if you, not that you guys need to write this down, but just remember that take the square root of the Pythagorean theorem right away. The square root of c squared is just c, and the square root of a squared plus b squared is right there. And a is just the difference in x's, and b is just the difference in y's. Nothing tricky there. All right, so those, you should be well versed in those 3 formulas. Now let's kind of go through and talk about this. Quadrilaterals and useful properties. In each blank, write A, B, C, or D, stating which formula should be used to verify each property. So we're talking midpoint, slope, and distance. So if we wanted to prove the opposite sides of a parallelogram are parallel, what would we use? A, B, C, or D? Yeah, remember A is, we use the slope formula to prove parallel. B would just use the slope formula to prove lines are perpendicular. Okay, opposite sides are congruent. What would we use? D, right, for the distance formula. How about diagonals bisect each other? C, the midpoint formula. And how about one pair of opposite sides are congruent and parallel? Well, for congruent, we would need the distance formula, right? And for parallel, we'd need the slope formula. All right. So when you want to prove a rhombus, okay, when you want to identify a rhombus, you want to prove that all four sides are congruent. What would you use there? D. Good job. And when you want to prove diagonals are perpendicular, what would you use? B. Okay, rectangle. Parallelogram with four right angles. So adjacent sides are perpendicular. What would you do there?
B.
B. Very good. And diagonals are congruent. D, right? Okay. So you'll notice we want to prove out a square. There's two important things for a square. First of all, we want to prove it's a rhombus, and we want to prove that it has four right angles. So we'd want to use D to prove all four sides are congruent. We'd want to use and then we'd want to use, where is it? B to prove that the sides, the adjacent sides are perpendicular, right? All right, finally a trapezoid. All we have to do on a trapezoid is prove that one set of sides are parallel, so we would use A. And an isosceles trapezoid, we have to prove that one set of legs are congruent, which would be the distance formula, and that diagonals are congruent would be the distance formula as well. Okay. So let's take a look at number one. All right, to me that looks like it's a square, but it might only be a rhombus. So the first thing we should do is possibly find the length of all four sides. That would tell us if it's a square or not. Now, typically it's usually harder to find out whether sides are same length using distance formula. I know you guys aren't fond of using that distance formula. Okay? But we could prove it a parallelogram first by proving these two sides congruent and parallel. That would prove it's a parallelogram. And then if we prove this side congruent, that would be enough. That would mean we only have to prove three sides congruent instead of four. So let's call this A, B, C, and D. So we want to list the four sides. And then let's identify where they are. So A is at 1, 1, 2, 3, 4. So we'll say it's at 1, 4. B is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So B is at 4, 7. C is at 4, 5, 6, 7, 4. And D is at 4, 1. All right, so let's find the length of AB first. So remember, when we want length, we just put AB with nothing over. That means length of AB, and it really isn't that bad. We want to do it nice and neat. I sure hope you will do it just like I do it, so that you can do it that way on a test and get full credit. So it is simply, I'm going to let you off the hook and not make you write out the formula every time, but it's just 1 minus 4 squared plus 4 minus 7 squared. Which means AB equals the square root of negative 3 squared plus negative 3 squared, which means AB equals the square root of 9 plus 9, A lot of you made mistakes in the last test saying that negative 3 squared was negative 9. Negative 3 squared means negative 3 times negative 3, and a negative times a negative is a positive. So AB equals the square root of 18. Now the nice thing is all we're trying to do is prove them congruent, right? So let's just leave it like that, and let's find the length of BC. Okay, BC is just the square root of 4 minus 7 squared plus 7 minus 4 squared, which means BC, am I going too fast? Equals the square root of negative 3 squared plus 3 squared, which means BC is the square root of 9 plus 9. Square root of 18. All right. So let's find the length of DC now. We're almost done. DC is the square root of 4 minus 7 squared. 1 minus 4 squared. DC equals the square root of negative 3 squared plus negative 3 squared, which I think we can jump the gun a little bit, and we know it's a square root of 18, isn't it? So we know that all three sides are congruent, which doesn't prove this is a square, because this guy could just still be cockeyed, right? So we've proved these two guys are congruent. If we just prove these two guys are parallel, then we've proved that it's a parallelogram, and if we prove these two guys perpendicular, then we're good to go. We know it's a square. So let's start finding AB, the slope of AB. So I'll say the slope of AB is, remember, delta y over delta x. So I'm just going to go 4 minus 7 over 1 minus 4, which is negative 3 over negative 3, which equals 1. So we know this guy is equal to 1. And by the way, we know these three guys are all congruent, don't we? Let's find that slope of DC. So the slope of DC equals 4 minus 7 over 1 minus 4. And you can see that's the same, isn't it? So it's just negative 3 over 3, or 1. So now we've just proved that AB and DC are parallel, haven't we? So let's put those little arrowheads on there. But remember, a way to prove a parallelogram is to prove that one set of sides is congruent and parallel. So we prove this is a parallelogram. And one of the rules or properties of a parallelogram is opposite sides are parallel. So we also know that these two guys are parallel. And opposite sides are congruent, correct? Are you with me on this? Yes. When we prove these two sides are parallel and congruent, we prove this is no, we proved it's a parallelogram. When you prove opposite sides are parallel and congruent, you prove parallelogram. Oh, yeah. Now, we proved, and parallelograms, opposite sides are parallel, opposite sides are congruent. Now, we proved these two guys are congruent, but we also proved that these two guys are parallel and congruent. So now what we've proved is what? We've proved a parallelogram with 4 congruent sides, which is a rhombus. If we want to prove it's a square, we have to prove it has 4 right angles. So we know this is a rhombus. By the way, also we know it's a rhombus because diagonals are perpendicular, aren't they? If we want to prove it's a square, we have to find the slope of this guy right here, and we're hoping it's the opposite reciprocal to that. So let's find the slope of BC, which is 7 minus 4 over 4 minus 7, which is 3 over negative 3, which is negative 1. So AB is perpendicular to BC, isn't it? Which means we've got a right angle right here. But you remember in a parallelogram, yes?
Okay, so for measured angle DC, is there supposed to be a negative one? If you put a positive, it's negative 3 over 3.
Where?
In the DC.
Oh, then 1 minus 3, 1 minus 4 is negative 3. So I left the negative off there. Thank you. All right, so, well, we could do the same thing and continue on, but remember, one of the other things we know about a parallelogram is consecutive angles are supplementary, aren't they? So if this is 90, we know this is 90. And if this is 90, we know this is 90. So we just proved 4 right angles. We know that all 4 sides are congruent. So this thing is officially a square. Okay? I'm going to leave the rest of those for you to work on because, to be honest with you, I want to go over your tests.